Hello and welcome back to my fourth programming language tutorial series. This is episode 5 in the series, and today we're going to be talking about loops. Well, let me get into a GeForce shell here. So loops work pretty much the same as they do in other languages. There's direct comparisons, obviously, except they're stack oriented, reverse Polish, backwards. So for an example of a normal loop in a slightly more popular language like Python, you would do for I in range, and then you would define your range as like 10, and then you put your colon, and this would be your for loop. Pretty simple. It's just going to print, 10 times starting from 0. Now in fourth, you do a do loop. So you would put a 10 on the stack, you put a 0 on the stack, and then you do, and then loop. And now your loop would go in between here. That's your body. Essentially what this does is it takes the second to top and the top number, and it takes them off the stack, and it will loop until this top number is equal to the second to top number. So until then, it will continue executing whatever is inside of here. So let's look at that as a good example. So let's do a, print 10. And let me make sure that that's valid. Okay, so we can put a 10 on the stack. Actually, we'll do 11. It's non-inclusive. We'll do a 1, and we'll do, and we're just gonna put I on the stack. Which, another cool thing about fourth is you don't actually have to declare an index variable. It's automatically declared. So this I, you don't have to declare it at all. It's just there in the loop. There's always an index variable, which is super helpful. So you can just put I on stack, you can pop I off the stack, and we can loop. And that's our for loop, basically. It's going to print 1 through 10. That, now print 10. There we go. And we can put a carriage return here if we want. Just to, there we go. Give us a little bit more of a vertical orientation. It's a pretty good example of a do loop. Okay, so the next type of super common loop that you see in most other programming languages is a while loop. So while for loops are usually the definite loops, they're non-conditional and they're just looping X amount of times, unless you're using like Java or C, which have they have the conditional logic in the middle. Most other languages don't do that though. So you would use a while loop. So you would do while, and then you would declare a condition like while 10 is, or while like I is less than 10, like that. And that would be like a while loop in Java. In fourth, we use what are called begin until loops. So you see this, you use this kind of format, and essentially this begin until, the begin marks the beginning of the loop, obviously, and everything in the middle is just going to loop until the until sees that the top number on the stack is anything other than 0. If it's anything other than 0 at the end of this until, it'll stop. So let's put this into a test. So let's make a countdown word. So countdown is going to have a loop in it. We're going to begin by basically adding 1 to the stack, subtracting. So we're going to be incrementing by -1 off the top number of the stack, and then we're going to be printing that value, and we're going let's do a carriage return and then a print, actually. I think that will look nicer. And then we should add a 0 to the stack equal until this. So let's just go over this one more time. We're going to start the loop. We're presuming that someone, when they call countdown, puts their own number that they want to count down from on the stack. So you would call this, you would put an 11 on the stack, you would count down, and essentially this will add a 1 to the stack, subtract the 2. We're going to put a carriage return, just a print line, and then we'll output that number, and then we'll check, oh, okay, we're going to need a duplication here, just really quick. All this is going to do is going to keep, it's going to keep a value on the stack, essentially. So now it'll have something to compare to. We're going to keep that final value. And now if we enter and we do 11 countdown. Oh, stack underflow. It got to 10. All right, well let's go through this. Let's pretend we're the stack. Fourth is pretty easy to debug because you can actually map it out the entire way. So you're starting with an 11, and we're adding a 1, then we're subtracting. So now this gets canceled out, and we have a 12, or we have a 10, and then we're duplicating the 10 to create another 10. We are entering, we are popping the 10, we're adding a 0. We are then checking to see if they're equal, doing 0 because they are not equal, and then it is right. Okay, I see the issue. I believe we just need a second duplication, and that might solve our issue. There we go. So that was pretty simple. So now, as you can see, we count down from 10. I think that's pretty solid. We can do with bigger numbers too. 101, and it's fast too, really fast. Let's go 10,000. Done. And Replic's not gonna let me scroll up all the way, but as you can see, it definitely did happen. We could go bigger too. I mean, like, hell, dude, let's go 100,000. And we can just watch the numbers scroll down. Oh, REPL's crashing. Alright, I'm going to stop that because REPL crashed when I tried to run. Not a big fan of big numbers. Alright, let's just get us back into a new shell. Okay. So those are kind of the basics, do loop and a while loop, basically begin until. To end things out, let's solve the classic interview question of FizzBuzz in fourth. It's relatively simple. It might take a moment to work through the answer, but if you're not familiar with FizzBuzz, essentially what it does is, given n, you're supposed to count upwards to n, and you have to check each time if that number is divisible by 15, 5, and 3. And if it's divisible by 15, you print FizzBuzz. If it's divisible by 5, you print Buzz. And if it's divisible by 3, you print Fizz. Else, you print the number. It's a relatively simple problem with simple solutions. In Python, it's just I in range of 100, and then we would I can't exactly write this out because I can't do multiple lines without it giving me an error. But essentially you just do like if I mod 15 is equal to 0, print FizzBuzz, else if. I think you get the gist. So we just have to recreate that in fourth. It's not too hard, so let's let's see, let's create our own word called FizzBuzz. For this, we might actually want to move over to the actual file here, just because it's a little bit easier to do multi-line stuff, a little bit better formatting. So works the same as the console. We do FizzBuzz. So step 1 is going to be starting our loop. So let's start 101 to 0 or to 1, and then a do loop. And we'll come down here, we'll define the bounds of the loop. So now inside of our do loop, we need to check if I mod 15 is equal to 0. So let's put I on the stack. Let's put 15 on the stack. Let's do the operation. Let's put 0 on the stack. And now let's check if they're equal. We'll do if. And now let's come through here. Let's add a then. So this is going to check if that's good. So then let's print, make sure there's space there, FizzBuzz. And we will do a carriage return as well. Okay, and then let's say else, yeah, it's not that. So currently, what will we have on the stack? 0 at the time of this else statement. So we want to drop the 0. And then we will want to add I to the stack again. We'll add 5 to the stack. Oh, I also just realized we have to put a mod operator, not the percentage sign, which is what you would use in a lot of other languages. Forth uses mod though. Drop I. Okay, so we drop the top of the stack, which is 0. Then we add I. We add 5. We do mod. We add 0. We check if they're equal. If they're equal, we will print. We're going to print cr dot print buzz, and let's say else that's not it. So else we will drop the 0, I3 mod 0 equals if, and we'll do carriage return dot fizz. And let's say all else fails. Oh, let's add a final then as well. Yeah, all else fails, we'll do carriage return I dot. Oh, and let's drop the 0. It doesn't really matter, but just for a clean stack. And I think this should work for FizzBuzz. So let's try it out. There's only really one way to find out. We just call it, run. Yeah, alright, so now as you can see, starting from 1, going down to 100, we can see FizzBuzz works. So it's just a simple little puzzle interview question that's meant to make you think quickly. Very simple stuff though, easy in Forth, and it's also easy in every other language. But yeah, I think that's going to conclude the tutorial today on loops in the Forth programming language. I hope you enjoyed. Thank you for watching. Bye.